All right, you guys, so this is an interesting video today. We're talking about the magic sauce that actually makes a helicopter fly. We're looking here today again at the Cabri helicopter, and there's one component, if there's anything on a helicopter, which there's thousands of components on a helicopter that are just mind-blowingly amazing at how they work. If there's one that I've thought about from when I was a little kid until now of how it actually works is probably going to be the swash plate. Okay, so the swash plate is right here. There's actually two swash plates on the helicopter. There's a lower non-rotating swash plate and then an upper swash plate. So you can see both of them right here. They're stacked one on top of the other. The lower one is non-rotating, so it's fixed actually to the mast of the helicopter, and it's got a link on it that holds it in position. And from the cyclic controls in the helicopter, there is linkages that go to what they call typically a spider or a control orbit down underneath. And then that, connected to that, is pitch rods. Okay, so you see these little guys here? These are called control rods or pitch controls. And so the lower ones, the longer ones, are pitch rods, and these ones are pitch links. And from those pitch rods, they come up and they connect to the lower swash plate. Okay, so that's the non-rotating swash plate. Stacked on top of that is the rotating swash plate. That's this swash plate right here. When I move the blades of the helicopter back and forth, you can actually see as they rotate, you can see this upper swash plate is actually rotating along with the rotor blades. Okay. So now inside of here you have two different bearings. Okay, so one bearing is attached to the two different swash plates, and it's a spherical bearing. It allows those two swash plates to actually rotate around in a spherical direction. Okay, so if you move the cyclic around, let's say you move the cyclic around in a full circle. Okay, what you're going to see here is that swash plate is actually going to move around in a circular motion like this. Okay, and then we can put it back to the center, and if I were to, let's say, raise and lower the collective, you're going to see both swash plates come up and down. Okay, so here comes the collective all the way up, and then the collective all the way back down, and those swash plates move all the way up and down. Now the second bearing inside there is a rotating bearing, and that's what allows the mast to rotate inside, so the drive shaft here to rotate inside these two swash plates. Okay, so the magic is transferring motion from a non-rotating part, which is the lower part, to a rotating part, which is the top part, and allowing the control inputs from the lower portion, from the cyclic and the collective, to be translated to the upper portion. So now we've got the rotating swash plate up here with the little pitch links here, which now connect directly to the main rotor blade, and that's what changes the pitch angle on the rotor blades. Okay, now I've talked about this in a different video before, but depending on which control input you're making, it's going to affect each blade differently. So if we raise and lower the collective one more time, let's see that. So you can see this upper swash plate. The whole thing is coming up and it's coming back down, and all three of these pitch links right now are raising and lowering at the same pitch angle, which is causing each of these three blades to increase and decrease its pitch angle at the same rate. Okay. Now, if I were to move the cyclic fore and aft, okay, you can see what's happening here now. What's super interesting is the cyclic is getting moved forward and backwards, but the change is actually happening over here. There's something called phase lag, and phase lag means when you're changing rotation on anything, the reaction to whatever input that you're making is actually going to happen 90 degrees later. So when you push forward on the cyclic, this side of the pitch, the swash plate actually tilts down. As that blade rotates forward, that reaction is going to happen 90 degrees later at the very front here. So the blade is actually going to reach its maximum downward pitch angle at the very front of the helicopter, which is over here. And then as it comes around to the back, it's going to do the same thing. Conversely, so left and right cyclic is going to do the same thing. Okay, so you can see here and here, the reaction to that is going to happen 90 degrees later over here. Super short, super simple little video. I hope you guys found it interesting. Super exciting part of the helicopter. I think it's really awesome. There's a Cabri coming in for landing, so I've got to stop this video right now. If you liked it, give it a thumbs up. We're going to talk to you guys in the next one. See ya!